I'm going to find the general solution of this differential equation. So let's see the answer. So first here writing the given. So 1 plus x square and here dy by dx. Then after minus x and here this is now 2 tan inverse x. Now the next is here we can put x place in the one side. So this x moving on the right. So this is here 1 plus x square and here dy by dx. Then this we can write 2 tan inverse x and here x. After that now we can write, so this is dy by dx and this is here 2 tan inverse x and this is now we can write 1 divided by x square. And after that the next is here this we can write x. So this we can write x divided by 1 plus x square. So after doing this one, now the next is, so here dx putting on the right side. So this we can write dy and this is now 2 tan inverse x and here 1 plus x square and here this is now dx. Then after x 1 plus x square dx. Now x placed in the one side. After that take the integration on the both side. So integration here dy. Then after this is here 2 and tan inverse x divided by 1 plus x square dx. Then after here x dx divided by 1 plus x square. So this we can write. Now the next is here. So if I do the integration of dy, that is equal to y. And this is here one more line going to write tan inverse x and here 1 plus x square dx. And this is now x dx and here 1 plus x square. So after that let's say I1 equal to integration tan inverse x 1 plus x square. So if I assume this is now z, okay, so if I assume u equal to tan inverse x, then here du equal to 1 divided by 1 plus x square and here dx. So this we can write. So this place we can write here du. Now I1 equal to, so this is here tan inverse x that I assume u and this place we can write du. Now u differentiation that is equal to u square divide by 2 and no need to write c there. If you want then you can write, and u that I assume tan inverse x. So this is here I1 value is now tan inverse x whole square divided by 2 plus c. So this is here tan inverse x. Now this side going to calculate I2. So I2 is now x dx divided by 1 plus x square. Now let's assume v equal to 1 plus x square. Okay, then here dv equal to, so 1 differentiation 0, x square differentiation 2x and here dx. So we need to get here dv by 2 and here we can write x dx. So x dx place we can put here dv. Okay, so now I2 going to write integration symbol x ds, we can write dv by, and here 1 by 2 we can write. Then after 1 plus x square, that I assume v. So now here I2 value 1 by 2 log v, that come, and c is the constant. So 1 by v integration log v. So this is now I2 1 by 2. So v place we can put log 1 plus x square, and here c. Now the next is y equal to, so y equal to, this is here I assume, so 2i plus 2 I1 plus I2. So I1 place we can put the value 2. I1 is now tan inverse x whole square divided by 2, and I2 value is now 1 by 2 log 1 plus x square, plus c is the constant. So this is 2 to cancel. Then here y we can write tan inverse x whole square, and after that this is now 1 by 2 log 1 plus x square plus c. So this is the required solution of this given equation. So this is the way we can calculate. It's look lengthy, but you only need to follow the steps. So put the x place in the one side, then here after putting, then take the integration of the both side, and here to make the simple, let us assume this is I1, this is I2, and after doing the separate integration, put the 2 in the one place, and finally you get your answer. So this is the way we can do the integration. So now in this video it's over. So thanks for watching. See you next to it. Thank you.